As ingestion runs, files are created and pushed into the deep storage service you've provided to your cluster. As containers for your table's data, these OLAP-optimized files, known as segments, are a fundamental building block of Apache Druid. The location of each segment, together with other information, is recorded in the Druid metadata database. Your cluster's retention rules are triggered regularly against this data, prompting distribution and replication of segments around the cluster. This distribution to the local disks of multiple query processes is how Druid is able to execute massively parallelized queries, helping you to achieve sub-second query response times. Apache Druid looks for efficiency in two directions: downwards to the segment data as it's processed, and upwards in planning what segments to process. According to the configuration you apply to your ingestion, segments are generated that cover a particular period of time and optionally clusters of dimension values. Druid is therefore able to use the time period and dimension values in the where clause of select statements before it has to do any segment processing. It can work out which specific segments need to be scanned and only work on those. Consider a select statement covering 5 days, where you have segments covering a day each. Druid can create a plan where only 5 segments of the table are going to be processed, rather than having to do a full table scan. Segment processing is parallelized across the data processes, 1 segment per thread. The more free CPU threads there are in your cluster, the more segment scans can be done in parallel. For a query spanning 5 segments on a cluster with 10 free CPU threads, there's the opportunity for all 5 days' worth of data to be processed in parallel. Maximizing the potential for parallelization through good balance and replication is a key responsibility of the data management processes in Druid. It pays to familiarize yourself with how this process works and to check that the configuration meets your needs. You can reshape existing data using compaction and reindexing. These allow you to change the partitioning of a table in place when your needs change. If you're working with streaming ingestion, it's particularly important to configure automatic compaction. This automatically applies a defined layout over time. Parallelization has its limits. Even with 1 million free CPU threads, you can't get sub-second response times if each of the segment files takes 10 minutes to process. That's why there are some things you need to think about at the segment level where you're aiming for that response time. You may have already spotted that Druid has a default maximum tipping point of 5 million rows before a segment is produced. This is based on the experience of the project's committers and contributors, keeping segments small enough that they can each be processed quickly, but large enough that the overhead of opening and processing each segment is worth the effort. Segment files are columnarized, making values local to the question that we're asking. This is a well-established technique to power column-wise statistical analysis. Without columnarization, each Druid process would have to read every row left to right from a segment when it processes it. With it, it only has to open and process the columns of interest. But to reduce the need to look at the data inside each column row by row, your table data can also be indexed. Druid employs dictionary encoding and adds a bitmap index. This speeds up filtering operations, especially binary filtering with or, and not, etc. Be aware of what you are using for the segment row limit, your data distribution rules, your dimension indexes, and partitioning and clustering. Understanding these is an essential part of capacity planning and of troubleshooting performance. Consider that a where filter on dimensions that you are clustering by could prove to be faster than merely applying an index. And keep an eye on your queries. Understand how they will execute in the context of these things, like how time periods directly affect the queue of segments to process. And finally, don't forget compaction, automatic or manual, and reindexing to look after these fundamental building blocks over time.